Hey guys, Erik here, getting ready to play with some carbon fiber, making some Mini A100, and I'm just going to show you some of the progress. Alright, so I just finished the back side, and now I just flipped it over. We're going to do the top side. Obviously I'm not taking off the mask because carbon fiber is still hanging out in the air, and I don't want to die. So, here we go. Alright, so a little ways into the top side of the Mini A100, I noticed that all these holes are about ½ an inch to the left. So I gotta go find my brother, see what's going on, and see if we can fix it. We're gonna try this again. We found the problem. We have some faulty wiring here that keeps on skipping up the axis, so we're going to try the back side, do one more, and see how it goes. Alright, so just got done with the custom engraving for our friend Norman there. And yeah, he's got the NukoTools face. I don't know what else to call it. Turned out pretty wicked. Getting ready for the next tool change, and we'll see how the rest goes. Alright, so we got one side of the Mini A100 cut out, and then once we get to the other side, we had another little issue. Our wiring connection started freezing up and made it so the axis wouldn't move, and it just wanted to cut into the hole down and screw up the whole thing. So, good times all around. Think we're gonna have to do something about these silly little connections here that keep on giving us a lot of problems. So, till we figure that one out, thanks for watching.
Alright, So I have had a very terrible day at the dentist. I got a tooth pulled. I feel like crap. It's really starting to hurt now. Still bleeding like 3-4 hours later. Anyway, I can't stand sitting still, so I'm in the garage. Erik did a good job making the handles. The frickin' machine kept breaking on them. The problem being this wiring connector. The motor would just go stupid and forget where it is. And so anyway, I replaced this, hardwired. So I said, screw you connector, I'm just going to hardwire you and you'll be better and good forever. And I also wired the, I connected them in a different pattern. I connected, let's see, it used to be bipolar series, now it's bipolar parallel. And all you machinist nerds will know what I'm talking about. This way you're supposed to get like 30-40% more power to the motor and let you get faster rapids and all that stuff. So whereas before I was getting rapids like, this is 40 inches per minute. That was my rapid. Oh, it's set too high right now. But, this is 120. That's more like it. Still a little, especially at the end here. But yeah, 100 would be perfect. Anyway, so that's that. Since I'm here and I know how to do it, I'm going to rewire the Y and the Z because I get more power, and more power is always better. And there's another thing you can build and install here. It's called a rattler, and it dampens the vibration. It's sort of like a flywheel effect, as well as torque. I don't know, crank balancer thing in a car. Takes out the vibrations and lets you get even more rapids. Yay! So this set of handles, it's going to have a little bit of a dent from where the motor skipped, right there. But we're going to finish them anyway because they're awesome. And we'll see how bad the dent is. Since we screwed up, Norman of course will give you a discount, but I think you should still accept them because they're wicked awesome and they're not going in garbage. So we'll see how they look. Interesting development while Erik flips his valley saw. So I got this rewired and I start moving the motor, and I actually had a big blowtorch trying to get this heat shrink tight. And Erik's like, dude, I see sparks. The bottom of the wiring connector here on the bottom of the motor, you can see how pretty much all those wires are split and the middle one is charred. Can't quite get it to spark at the moment. But they're screwed. And it's just because this wiring is going like this every time I move it. And I've had this machine running for, I don't know, 2 years. So this Y motor doesn't move, it's the carriage that moves. So the Y stays still, the Z stays still. This is the only one that's seen all the action. So I do have a spare motor, but I'll have to rewire it just like I did here, which means I'll have to de-wire that, which is dumb. Maybe there's a better way. So there's your problem. I'm pushing the same direction every time, so it's supposed to only go towards the right. You can hear the motor stalling out. It's because these wires right here, holy shit. Pardon my French, but that's toast. Okay, so I got everything wired up. Been out here wiring for about 2 or 3 hours now. If you see in my hand right here, There's a big heat shrink section of wires where I got rid of the connector. And so I rewired the X, the Y, and the Z. Got rid of the connectors on all of them. Turns out the connector wasn't exactly the problem. It was the motor here, this joint. But anyway, getting rid of the connector allowed me to rewire them like I explained before. See, to me this was 3 hours ago and I've forgotten about it already, but to you this was 3 minutes ago. Anyway, I'm getting much more improvement, much more performance from having them wired as bipolar parallel. So to all you guys building CNC machines, don't even waste your time with unipolar, don't waste your time with bipolar series. Go straight to bipolar parallel, because I had a bipolar series before and the motors would get too hot to touch after about an hour of being on. And now they're hardly warm at all. They haven't been on for an hour, but for a while there I had one wired the new way and the other wired the old way, and you could feel a huge heat difference. The new way of wiring was way cold and the old way was hot. They're quieter in this idle mode, and I have way more rapids, way more speed. Check this out. All you guys running industrial CNC equipment will laugh at this, but for me this is huge performance. Before I was getting 40 inches left and right, which is about like this. That's 40 inches. Here's 100. And I was getting 40 inches of Y as well. This looks like that. And this is 130. And I was limited to a meager 15 inches per minute of Z up and down, which is really pathetic. That's unacceptable. And I've got it at 40 now, which is good. Currently I don't have any support for the head. This is about at least 40 pounds of steel, cast iron, whatever, being pulled up just by the motor. There's no shocks, there's no springs or anything assisting that. So that's why I'm limited to 40. I have a gas strut that puts out 40 pounds that I'll connect from here to the base, and that'll support all that extra weight, which means I should be able to get even faster rapids. That, combined with the rattlers that I explained before, this machine might actually start making me happy. So, yeah. Let's see, am I going to make this 2 videos, or am I going to make this combined as one? I think I'll just combine this as one video. So now that everything is finally working properly, it's time to finish up these carbon fibers. It's like 10 o'clock at night. I'm probably not going to do it tonight. But to do that, I will have to remove the plate, the carbon fiber, remove it off the machine. There's a 0 hole on my fixture plate hidden by the carbon fiber, hence the reason to remove it. So I will zero everything again on that hole, zero the tool on the surface of the plate, of the carbon, obviously put the carbon back on, and since it's pinned, it's pretty repeatable. And then we go ahead and start the coat halfway through and finish the handles. They're almost done. You got to finish profiling and do the corner rounder and thumb groove and stuff, and it's done. So I guess we'll do that tomorrow. And oh, one more thing, since we're doing this, talking about this. Yeah, you can see here. This, okay, so if the motor's hanging like this, the motor's moving like this all the time, and this is what caused the wiring to fail. This is a new motor that I have. It's got hardly any use to it. So this was Eric's idea. Being thrifty car guys, we have zip ties everywhere. We're going to wrap this wiring harness tight up against the base, or the body here. Zip tie it. And then cinch that down. That way this open connection here is going to be cinched. It's going to be tight. That's not going to see any strain. The strain is going to be on this rubber hose, which I did on purpose. You know, that's the reason for this rubber hose. So that'll solve this problem, prevent it from happening again in the future. And that is that. Okay, that one? Where's it go? It goes in there? Where does it go? In there? Good job. Well, we can't do it because there's no air pressure. See? We turned it off. It's okay, we'll try it again tomorrow. Good job.
Alright, so we got all our problems fixed and just got done with the corner render, doing the last little phase.
Eric's outside doing an awesome job sanding these up. Ah, you didn't see that. They're carbon fiber, they're indestructible, right? Yeah, those look wicked. Alright boys, they're all done. They turned out freaking fantastic. So earlier in the video, remember we said we had a problem? That was all the damage left from that. Could have been a lot worse. I'm glad we were able to save them. Obviously it's a problem, it's not perfect, but they're still amazing carbon fiber handles.
All right, thanks for watching, guys. Cheers. Bye.